for group number 2.
Okay. Hello everyone, I'm Panos Labropoulos from Bright Computing. I'm responsible for the deep learning stack. So most of my talk will be focused on the deep learning aspects, even though EasyBuild can be used for other HPC tasks. So Bright Computing is an enterprise infrastructure company. We have a product called the Bright Cluster Manager, which manages all sorts of cluster systems, from HPC clusters, which was the first type of system we supported, but also Hadoop clusters, deep learning clusters, and OpenStack clusters, and even database clusters. The company was founded in 2009 in San Jose, California, and we also have our European headquarters here in Amsterdam. Regarding customers, we have customers both in enterprise. You saw a picture of a Boeing plane. Actually, Boeing uses Bright Cluster Managers in all the data centers. But there are also many other big customers like CDA Davco, Tesla, Illumina, Fotis from Illumina is here, Rose, and other pharmaceutical companies, for example, Novartis, are using Bright. Then there are also several government organizations that use Bright, like several federal funded centers like the Oak Ridge or NERSC in the US, also Los Alamos, Sandia, etc. And then Bright is also used by many universities like Houston, Stanford, Maryland, UMBC, etc., MIT. And that's only a partial list. I don't include everything. It's similar for Europe. It's also used both in the industry and have several industry partners. I guess the largest one in Europe, most likely, is still Rose Genentech. It's also used by several governments as well as educational institutions, and similar in Asia. So in total, it's used by more than 600 distinct customers split in all those verticals. The majority of the customers are in the US, and that's about 60%. So Kenneth yesterday saw the map where most of the EasyBuild users are coming from Europe, or at least all the hits. But actually, now that Bright is shipping EasyBuild and it gets installed on all those systems, actually that might get shifted the other way. Bright is also included in some systems, so you might not know, for example, the Cray and systems, which are storage solutions, are actually using Bright to manage the storage nodes. Also, DirectMon from DDN is actually Bright monitoring run underneath it. And also in some of the large communities like Cori at NERSC, the management nodes are running a Bright Cluster Manager, even though the users do not see that. Some of the clusters are not in traditional places. For example, PGS has clusters on board their seismic research vessels, because it will take too much time to see the data. It's also too expensive to ship 1 petabyte of data over a satellite link, so the data gets processed in place, and then only the processed results get sent to the land. Some of the clusters are not even collocated. For example, there are clusters that the management nodes might be in one place, like Singapore, and then they might be provisioning and running jobs on another place, like Sydney, Australia. For example, this is the Infinity Cortex between A-Star and NCI, and it uses a 100 gigabit InfiniBand link between those two sites. Also, Bright runs some dark sites. Some of them we don't really know about. We know that one of them, for example, is the NSA, but several others are just completely unknown to us. And usually get a call from a strange guy saying that we're using Bright to have this problem. Help us fix it, but you're not going to say anything, we're not going to give you any data, just help us fix the problem. So this is a map of the Bright use at the moment. You can see that in most places where you have actually big HPC groups, Bright is there. Obviously, there is some gap in Africa, which hopefully should change at the point. Bright is also the de facto cluster manager for several OEMs like Dell, Cray, for example. Cray actually switched from ACE to Bright. So all the new Cray systems actually come with Bright pre-installed. HP still offers a CMU, but Bright is one of the options that encourage, and at least for deep learning all the AI solutions from HP, Cray, as well as Dell are actually coming with Bright. So our users actually, we have 600 customers, completely distinct users, completely distinct applications. We have clusters from four nodes going all the way to more than 8K nodes. We also have a single user, so one guy buys a cluster or one researcher and uses completely himself. But you also have clusters where you have at least 3 million jobs a day. Especially in the finance industry, every transaction and every time the stock market vary, Excel submit a new job, and that creates millions of jobs per day. We also support multiple architectures and support x86, Power 8 and 9, and soon we're adding support for ARM 64. So we cannot actually focus on one architecture, but we actually need to cater all those different needs. We also need to support all the major enterprise Linux distribution, that's RHEL RHEL derivatives, Slash, as well as Ubuntu. And we don't have the choice of selecting one or the other. We actually have to support all of them at the same time. And actually many clusters are actually mixing architectures as well as distributions. We also need support to multiple interconnects, for example, InfiniBand, OpenPath, high-speed Ethernet, Rocky, Cisco USNICs, PCI bridges, or other fancy interconnects. Cray Aries, for example, iGorp, NVLink. And that's also, so if we provide them in API packages, actually they need to be able to understand all those different interconnects. And similarly for accelerators, we need to support whatever our users are using. And we support both bare metal as well as virtualized clusters. And Bright also has a second product, it's called Bright OpenStack, which is a certified OpenStack distribution. And sometimes, the workload runs either on bare metal, and especially in industrial applications, it's very often containerized. So, this is a picture that that's not very uncommon, actually. There are several sites that actually their cluster looks like that. So you have on the left side the traditional HPC component where you run HPC jobs on bare metal, but you also have a container. You also have containerized workloads, and you also have completely virtualized workloads. And sometimes, if you don't have local resources, those clusters extend to the cloud. For example, Illumina is looking at scaling their local workload to the cloud, just to be able to burst if they have the demand for that. The way that the Bright Cluster Manager works is that we have an integrated approach. So we designed a cluster management daemon written in C++, which takes care of all the daily operations from provisioning nodes, monitoring, generating configuration files, managing services, and also some other applications that are used for the cluster. It's designed from the ground up. For example, we didn't rely on using patching tools like Ganglia, for example, for monitoring, and other tools for provisioning, but we actually designed the whole thing as one block. It tries to minimize the resource usage, and the way that also allowed us to take advantage of other possibilities. For example, in HPC, we have different workload managers, but if you want to write the Python API to submit jobs, you'd have to do different stuff if you're using PBS Pro or LSF. But actually, we have taken that part ourselves. So we have actually provided common APIs. So it doesn't matter what your underlying architecture or what underlying tools you use for example, workload manager. You can use the same API to submit a job, and it's a completely Pythonic API. We also provide UI for managing the cluster because, we can face it. Not all sites have Linux system admins or HPC admins. Sometimes you can have a student or maybe a Windows admin that is tasked to manage a new HPC cluster, especially in the enterprise. So sometimes having a UI to manage a cluster, for example, reboot a node or provision it or change its kernel, makes it easy for those users. So this is the architecture. You have management nodes in the center which have the central daemon, and each one of the committee nodes runs a daemon. that communicates using the REST API, and all the operations can be actually found out from the management node to the compute nodes. As I mentioned earlier, Bright is also the only and de facto standard for several OEMs for the deep learning solutions. For example, if you go to the Dell website and look at their deep learning offerings, which are based on the C4130 system, you can see that the software stack is actually Bright, and similar one for the Crazy Storm. So in terms of AI and deep learning, this is a short list of not complete, but a list of users that use Bright. You can see some big names like Tesla and Samsung there, but in Illumina, but Novartis, but there are also some other universities that actually use Bright. Even Stanford, which are the developers of Caffe, are actually using Bright on the class to train the students because they don't want to rebuild the package themselves, but actually want to have everything prepackaged. Samsung, for example, last year, using the Bright packages and the Bright solution for AI, got the third place in the ImageNet classification challenge. This is like the top 500, but but we are actually benchmarking deep learning and computer vision solutions. And this is also a slide from Dell's website. So Nissant and Frank from Dell actually did some benchmarking on the Bright solution. And actually, one of our goals is to provide AI packages that are actually ready for HPC. So you just install it using a yum command, and is able to scale the system. So we don't take shortcuts. For example, if you use a container, for example, it doesn't have AVX support, but we don't assume that someone is going to run our packages on a laptop. It's actually running on HPC side, so most likely you have AVX instructions. And so we don't take all those shortcuts in optimization. This is the big data plus deep learning ecosystem. So we support all major frameworks. So in the core, you have the Bright Cluster Manager, which sits on top of the underlying distribution. But we also provide a number of libraries, and being in the software enterprise, actually, we have redistribution rights, so a user doesn't have to go and download CDGrand, for example. We are actually able to redistribute it, which makes life a bit easier for us. And we also have very good relations with those companies. So if, for example, we see or not a bug in CDN, we can actually talk to NVIDIA and get that fixed immediately. And so we provide those packages. Some of them are also have very restrictive license agreements, like TensorRT, for example, but we do have the distribution rights, and we built, all that AI stack around that. Another thing we do is that we don't limit our packages to only AI applications, but if you want to use them in the industry, most likely you have also an existing big data infrastructure or some type of Lambda architecture, for example, Hadoop or Spark. And as you know, when you compile Caffe, or let's say compile Tensor from source, you have the option to actually enable some bindings to all those technologies, and we actually do that. So the packages provided are also ready to be used and called from big data solutions. This is a list of our goals. So one of our goals is to make the libraries being able to be used in existing big data solutions. And that's very important in the industry, but not only. And to give you an example, let's take self-driving vehicles. You need to train a car to drive itself under any circumstances. But to do that, you need to provide some input data because it's supervised training. But some events are very uncommon. For example, it's very unlikely that you'll be able to sample data, for example, of a boulder falling off a mountain and run in front of the car, unless you're lucky or unlucky, and while you're collecting data, you drive there. So this data actually has to be synthesized, and to do that, you actually have to simulate the data, and that's actually a type of HPC/big data type of simulation. And you also need to pre-process the data, especially if it comes from sensors. For example, if it's images, you need to rotate them, crop them, etc. And this is a type of batch processing that can easily be done by Spark. So if you have that infrastructure, why not reuse it and try to write your own script to do that? And I mean, we also want to make it seamlessly and effortless to perform transfer between deep learning and leverage those models. Also, sometimes your data might reside in databases, and big data tools are very good at talking databases. So, I mean, adding those bindings actually can make it easy, for example, for any of those solutions to actually be able to talk to a database and not only data on a local file system. We also want to support not only images as the idea, because most of the deep learning examples we see focus on imaging, but we also want to support video as well as audio and natural language, because, for example, gene sequencing is actually a type of natural language processing from AI. You also want to enable, I mean, all popular bindings for Python, but not only that, also Java, Scala, and R for many of those frameworks. And the solution needs to be turnkey. For example, a user doesn't have to know about the dependencies. For example, if he wants TensorFlow, he just say, I want TensorFlow. For example, apt-get install TensorFlow, and all those dependencies have to be pulled. It needs to be optimized out of the box at least, and the requirements actually to scale to 64 nodes at least. It has to be a native application for the underlying distro, because we don't want to run into issues with linking to non-native libraries. We also don't enforce anyone to use Docker. For example, if you get NVIDIA's containers, you actually have to use Docker. But we don't want to enforce users that don't want to use Docker, either for security reasons or for preference to use it. And at least the pre-built packages need to be also be available using the native package manager distribution, because sometimes it makes it easy to maintain and see what's installed there, and not having to use the tools to see what libraries have on the system versus what HPC modules have. We always install on the shared storage, so you don't have to reboot or reprovision the nodes to send those things. We are very aggressive on the CPU part of optimizations, and we also integrate with several other technologies, like our Tensor packets can directly access HDFS and Amazon S3 if needed. And we also do QA testing, I mean, developer release engineering. I mean, we also support the native distribution, the native Python distribution, but we also add support for Python 3.6, and actually going to use the latest Python, first of all, because Python 3 is backwards compatible with other 3 versions. And secondly, we've seen that many of the examples that are out there, or even some of the code in some of the frameworks, is actually using features from other Python 3.5. For example, PyTorch is using, actually requires PEP 448. And actually, we've seen also some examples that use f-strings, which is a Python 3.6 feature. So we decided to go with the latest Python version. To install, I mean, any of those frameworks, all you have to do is yum install the name of the package that you want, for example, CNDK, and it will pull all the events that you require. And to prepare the HPC nodes, we don't install the framework itself there because it's on shared storage, but we actually have this meta package called CMML dsteps, which has only the common requirements for all the packages. So it's like a small meta package. For example, you will install the CUDA driver if it's not there. And the CUDA driver is the latest version for the Tesla line of CPUs, and it will be rebuilt for that specific kernel by a script inside that RPM. So if you don't have the driver, it will actually install it. If it's there, it will just install the other dependencies. And to load the package, you just have to load the name TensorFlow / the version, and then you're immediately able to use it. We also install all the development dependencies. So if you are, if you're a developer, and some of our users are actually power users, like at Stanford, they're actually developing Cafe. They don't care about using our source, but they actually have their own source tree where they make changes. So we provide all the developments that you can just check out the source tree and just build your framework. This is a list of frameworks, so it actually provides all the major ones. I'm not going to go into that list, but we also provide, some of the library dependencies, and we actually make sure that they're common for all distributions and also all architectures. For example, we standardize on CUDN 7, and this is common in all across all architectures and distributions. If there are any issues, either performance-wise or bugs, for example, we are actually going to work on fixing that with a vendor, for example, in that case, NVIDIA, instead of having to ask a user to use a different version. And because I think that's at least the right approach for in cases where those libraries are not open source. We also provide the list of Python modules, and the list of Python modules is not random. I mean, those versions are not random, but they're actually the result of testing exactly what works with each other, because it's very common that you install one framework and then you install another one, and then it actually has a requirements file. You just do pip install that requirements, and it actually updates stuff and break the other install frameworks. And this is something that is very hard to keep on. I mean, exactly what the Python, what version of Python modules you need for all the frameworks. So that list is very hard to come by, and actually the way we do that is actually just by doing unit testing and see. I mean, if an update would have broken something, and if not, we actually go back and lower the version. Up to now, I mean, the development cycle for deep learning frameworks is very fast, and it has been changing. For example, TensorFlow about a year ago, it used to have a new release or a major change every week or less than a week, or maybe every 3 days. And that was very problematic because you had the users that say, I want to use the latest one, and you cannot actually have a fully QA'd release every 3 days unless you are actually working on that framework and you're a developer of that. And what we did is actually, at that point, we're actually upgrading to the latest and greatest versions after going through internal QA every 2 weeks. So everyone was forced to upgrade, which was not ideal, because some users might want to stick with another version. And that became more apparent when TensorFlow went from version 0.12, for example, to version 1, where they changed some API things that annoyed users. And forcing the users from 1 week to within 2 weeks to update actually caused a lot of annoyance. And also, if you update that fast, actually have less time to do large tests or full tests, which means that the chance of breaking things is actually higher. And especially if you support that very large number of frameworks, and you have to, I mean, process all the changes that have happened in between. In some other cases, I mean, building from source is also optimized because it's also preferred. For example, you might want to use even more aggressive optimization flags, or you might want to make a change to the source code. And that's a solution we didn't have. So we looked at different ways to provide the users. Actually, I came up with an idea that most likely was not that smart, but I proposed to use to actually repackage our internal Jenkins infrastructures, because inside Bright we use Jenkins for our continuous integration as well as building our packages. We have a system on top of Jenkins called AutoBuild 2, which actually builds our distribution. And I say, okay, let's give that to the users, but most likely that's not user friendly. It's not very well documented, and many users might not want to invest in a complete Jenkins infrastructure if all they want is just get a package. Then, I mean, we looked also at Spark as another solution, and I think we had shortlisted either EasyBuild or Spark. And then we actually decided to talk to our users. So actually, this is an American customer. It's a university, and actually, we started getting tickets like that. And the user was asking us, "Does Bright support EasyBuild, or are you guys going to use it?" And we also talked to some people at ISC last year, as well as Super Committee this year, and asked them, I mean, if Bright was supposed to use one framework for building packages, what do you want? And actually, the majority of them, more than 6%, said we want EasyBuild.
Asking the users?
Yeah, we asked, I mean, Bright customers that either came to our booth, or we also have Robert Stauber, who is based in Escalon, California. He's our product manager. And he went and asked users, what do you want to see in Bright? What sense would you make? And if we would support one framework, which one would be? And so actually, EasyBuild was the one that came. And I mean, I would say that it was 6-4. So Yeah, but in any case, I mean, this ticket that you see there is actually is not the recent cycle came 4 years ago, and in between we actually got many more requests for EasyBuild, and as well as for this in Illumina, for example, we work together on LMod and making fix for LMod, but we are also using EasyBuild. So we say, I mean, we made the decision that we are going to go with that. One of the issues is that I mean, the toolchains that are in EasyBuild are actually not going to work directly with the compilers that we include. And as I said, I mean, several OEMs are shipping Bright, and one of them is Cray. So the Cray parallel environment always gets, or even the Bright compilers always gets installed in a standard way, in a standard location. So actually, we needed to provide additional toolchains, even though sometimes it might be the same version as what EasyBuild provides. But we need to make a distinction. So we actually prefix those with a CM. And I mean, in terms of DCC, we need to support DCC 5.4, 6.3 actually, not 6.4, and 7.2. As well as, and in the case of 6.4 and 6.3 and 5.4, we actually support both the new and the old C++. So I mean, 11 ABIs, because it's not very uncommon that a user might actually want to link or an application that uses with an old library using the old ABI. That's one of the cases. The other problem is that some of the deep learning frameworks are actually coming with prepackaged dependencies. For example, if you use Cafe2, it actually includes NPAC, it includes Nickel, it actually includes Nickel 1, which is not ideal. And I mean, one thing that you can do is either disable those things, or you have to make sure that the build scripts that are there, in the case CMake, actually would realize that we're using an ABI. And actually, that's not what is happening with Cafe2. And it's that's especially problematic when you use protobuf, because protobuf is a library that usually is never, linked dynamically. It's always statically linked inside your code. And if it has been using the new or the old API, you're actually not able to link anymore the rest of the libraries. You're also not going to support every version of CUDA. Actually, we are forcing the users to either choose between CUDA 8 and CUDA 9.1. CUDA 9.1 because it has all the fixed CUDA 9, as well as some performance improvements both for Pascal as well as Volta. And CUDA 8 is because it actually supports the old half operator. Actually, it doesn't have the half operators of CUDA 9 if you use generics. And that means that users have some old or legacy code can actually don't have to recompile it. So that's why you need to support both of those versions. And in terms of MPI, we can support MPI 1.10 and actually 3, because there are some API differences as well as MVABITs. Not for deep learning, especially, and the main reason is that most of the deep learning customers, at least in production, and at least in large-scale deep learning sites, are using Mellanox hardware, and Intel is not very keen on working with Mellanox, because they want to advertise OmniPath. And another thing is that, there is a debate between those two technologies, but in deep learning, what matters most always is bandwidth. You care more about memory bandwidth than clock speed. You care more about the fabric bandwidth than you care about latency, because the surface to volume is very high. You press most of the time, and then you transfer a large amount of data, but you're going to do it fast, so you don't have to wait a lot. But you don't interleave those two processes. So, bandwidth is more important. InfiniBand and let's say OmniPath have the same latency, but InfiniBand has a slightly better bandwidth. So, if you want the best, in that domain, the choice is clear.
So, can you provide it? So the customization is mainly.
Yeah.
Customization is mainly about the versions.
And also the locations, because you are not supposed to rebuild those. You just have to take them as they are.
Yeah, but no, so why has Bright considered just contributing back those tool chains?
Yeah, so that's a point I'm coming back in a sec. And I mean, especially for the Cray environment, which is relevant only for Cray systems, is that it always gets. I mean, there is a 25-page manual that Cray field engineers have, and it always has to be installed in a certain way. At least when you deploy a system to a customer. I mean, another requirement we have is we want to be able to reuse our modules, for example, OpenBlast or a protobuf. And the reason is that, I mean, you can recompile OpenBlast, but that's not ideal for every case. For example, when we compile OpenBlast, we provide 6 flavors. We provide OpenBlast as single-threaded, as using POSIX threads, and using OpenMP, and we also provide flavors using other 64-bit indices to make it more look like MKL, but we also use the 32-bit indices, which is mostly Atlas-like.
Are you guys concerned with the release management of OpenBlast?
Yeah, because we are very strong advocates of OpenBlast, and we actually also argued about performance benefits. For example, Intel MKL has very good performance when, at least in multi-node systems, when the number of processes is a power of 2. But if you had odd numbers, for example, OpenBlast actually performs better. So, I mean, there are some reasons to use OpenBlast, or if you don't have, I mean, Intel hardware.
Have you guys reached out to the OpenBlast maintainer?
Yeah. Not only us, but actually I know that Red Hat actually reached out to them as well.
Red Hat also did?
Yeah.
Did he actually reply?
Yes, but he mentioned the number of issues that are like personal, but it's very, I mean, at the moment it's a bit unnerving because you don't have another option. Yeah. I mean, you can get Atlas, for example, if you spend the time of tuning it. But the question is, does everyone want to spend time doing that? And is everyone comfortable using Fortran code and linking against Fortran?
Yeah. The guy is getting that much pressure already, and he's not fixing the issue.
Yeah.
Yeah, maybe there's more. Open source. Yeah. Maybe. Yeah.
Yeah, I mean, the ability to also generate packages is important for us, also for our customers. And and we are even thinking of using it internally at some point, so to build our own packages. So if you can generate RPMs or Debian packages, that's ideal. And also, what is very important is the ability to use containers. Singularity. I mean, EasyBuild supports Singularity, and that's or it's going to support Singularity. But that's one of the things that many of the customers are interested in. Actually, Dell is actually wants to package all those deep learning frameworks as Singularity containers from Bright. So that's very interesting to that OEM as well. But what we saw is that there is extreme resistance in the enterprise of going to Singularity, even though they are aware of the security issues with Docker. For example, if they have a user mount or bind mount their GPFS inside the container as a root and then accidentally deletes everything, that's not ideal for them. And I mean, it has happened. I mean, it's not anecdotal, but it actually has happened in a very large insurance company. So that goes for Rollins, but I mean, there is strong demand for Docker as well, and that's something that we are very interested in looking into. Another thing is that, I mean, if you use Docker, you can actually use also Kubernetes. So if you don't want to use a traditional workload manager, but use a container-oriented manager, that's also something that many users want, at least in the enterprise domain, and that's something that we need to look into. I mean, in terms of Bright, I mean, one of the immediate benefits is that I mean, it will reduce support load for us because there are some frameworks that we don't, or some packages like Bowtie that are relevant for some users, but we don't really want to support ourselves. So it's better, I mean, if they can get it from EasyBuild and we can help them do that. If we see an issue, we can actually report it back to EasyBuild. And but we don't want to take responsibility of that, especially because we're not experts in that application. So that will allow us actually to focus more on features that matter, like building binaries, support uncommon use cases. I mean, some users actually have very old hardware, like very old NVIDIA GPUs, and they're still going to run deep learning on those, like GTX 780, for example. It's several years old. I mean, we don't have a business interest in doing that, especially because it's not going to get them very far, and most likely they just take it 2 times more to run it on a CPU. So, I mean, you can actually provide the, EasyBuild configs for those users to just build it for that old GPU that you don't support, maybe using an older version of TensorFlow and CUDA, and I mean, focus on what is interested. The other thing is that, as you see, I mean, we support, 3 OEMs are actually using Bright, and they have slightly different hardware. So, I mean, EasyBuild can actually make it easy to provide optimized packages for that specific OEM instead of having to invest on, build infrastructure inside Bright to do that. So they can actually take that themselves, and they will not, will have all the dependencies that they want. They know how to, they will have reproducible builds, and then they can actually test it immediately. So at the moment, what we do is that we're actually building it for them, and then we create a repo, they get those packages, test it, and then that's a very inefficient way of having feedback. But if you can just make change on the source code and rebuild it on that cluster immediately, test it, it actually minimizes the time. The benefit of EasyBuild is, I'm not sure if the first is a benefit or not, but it's going to expand the EasyBuild user base, because suddenly EasyBuild will be used or be installed at least in many customers. We provide support on EasyBuild, but that means that they're not going to do consulting. We're not going to, if a customer says I want that custom package, but for example, it does not exist, we're not going to take the task of building for him, because we're not, we're a software company, we're not a services company. But if there is an issue with EasyBuild, we're going to try to report it back, try to see if there is a fix, help it and contribute back to EasyBuild. And also make sure that if there is a fix in between those versions, we're actually going to apply the patch so the system can get the new EasyBuild in the next update and don't have to worry about the EasyBuild part itself. And that actually makes us happy, because EasyBuild is actually split into, the repository is split into 3. For example, the framework, which is the base, the component, is a separate repository, so you can actually monitor the core issues there, and most likely security issues most likely will also be there. And we can actually split that. This is a much lower volume than, for example, looking at the easy configs or easy blocks, and it's also less detrimental if something goes wrong there, at least for the system. And obviously, we want to, report back issues that our customers, that user base encounters, so that EasyBuild gets improved. EasyBuild is already available now. Last Monday, 3 days ago, we actually released Bright End-1, which comes with EasyBuild 3.5.1. So you can install it. YAP zipper get installed. It's sim EasyBuild, and it installs it, and then you just load the module. You actually, again, prefix it with CM just to make sure that this is the Bright version and not some other module that the user installed, because we already have customers like Illumina that already use EasyBuild. And we are also going to have a Bright, at least deep learning easy configs and easy blocks repo on GitHub. And at some point, good luck. Also going to contribute some things back, because as I saw, you don't support all the frameworks. And even some of the, even for example, TensorFlow, some of the, you can also enable some other flags. And it would be good if a user, if you have, for example, an easy block, a user can select whether they want XLA support or not. And that also plays a huge role in performance. And also enable other features like, integration with Mesos or Kubernetes, if he plans to use that on not on a traditional HPC workload manager, but inside Mesos from a container. Yeah, I think that's it.
All right. Thank you, Panos. Any questions? How many people will be using EasyBuild inside of Bright to help customers? Do you have an idea?
What we want to train is, first of all, some of the developers and support to start using EasyBuild. For example, up to now, have been getting requests from a site, say, you guys don't provide MTAR or you don't provide Bowtie, can you help us build it? So we don't want our support to actually build it for them, but actually provide them the instruction how to do it on EasyBuild. That means that the whole Bright support team, as well as at least the Linux integration team, will be using it, which means that at least 20 people inside Bright, to some extent, will be using EasyBuild, as well as pre-sales engineers, because they need to advertise it and show it to the customers. Yeah. And also the documentation team, because they need to actually document it, how to use it.
Question from Guillermo.
So we are a customer of Cray. We have CS Storm, and it's not clear for me if we can use your software stack or we need a special contract. Can we install the EasyBuild new, or
yeah.
we need additional contract for that?
So the latest, the latest system from Cray at CSCS is actually a Bright system. So you're actually licensed to use it. And the things that you're actually one version behind, because you're using the version that was released last May, and EasyBuild was added in 8.1, was released on Monday. But next week we're actually updating Bright 8.0, so we're actually adding Bright to the 8.0 version, and we're also thinking of doing it also to 7.3, which was a release that was 1.5 years ago. So if you have a Bright system that was installed at least in the last 1.5 years, it will have that. But we don't do updates every day, because we don't want to force customers to download updates. So we do the updates every 2 to 3 weeks, and in the next cycle of updates for 8, you can get it. And since you're also using OpenStack, you mentioned how to use EasyBuild on OpenStack. But I'm not sure if you're using the Bright managed instances, which are actually virtual Bright clusters inside OpenStack. But that means that those virtual clusters actually have access to the CM shared directory, and that means that they can also see EasyBuild.